let's do some more challenging examples of determining the characteristics of a graph given a rational function. Reminder, horizontal asymptotes, if the degrees are equal in the numerator and denominator, you look at the leading coefficient to determine the horizontal asymptote. If the degree is higher in the denominator, the horizontal asymptote is 0, y equals 0. If the degree is higher in the numerator, there's no horizontal asymptote. And to determine vertical asymptotes, holes, and x-intercepts, you need to factor the whole function, both the top and the bottom. Any factor that cancels out creates a hole. Anything left in the bottom creates a vertical asymptote, and anything left on top creates an x-intercept. So let's do this example here. Y equals 4x over x squared plus 4. Horizontal asymptote. So you have to compare your degrees here. Degree 1 over 2. 2 is bigger, so that means my horizontal asymptote is y equals 0. If the degree is bigger in the denominator, the horizontal asymptote is 0. Now I need to factor it to come up with all my other pieces. The top doesn't factor because it's a monomial one term. But in the bottom, actually that's supposed to have an x with it. Sorry, typo. In the bottom, I can take out what they have in common. So they have an x in common, and I'm left with an x plus 4. All right, if you're having trouble canceling everything correctly, you may need to put parentheses around your x. And on top, it's 4 times x. So we have parentheses around our 4 and parentheses around our x. Those are technically considered two separate terms. If you want to cancel anything, it has to be a whole entire set of parentheses. So here we can cancel our x's, which means that we have a hole at x equals 0. Anything left in the denominator is my vertical asymptote. So that would be at x equals -4. And anything left in the top would be an x-intercept, but in this case, 4 equals 0, there's not an x piece left on top. So there are no x-intercepts. And that's always going to occur whenever your horizontal asymptote, oh, that's a lie. Sometimes you could have special cases where you have an x-intercept even if your asymptote is 0. So, next example, x squared minus 9 over x squared plus 2x minus 8. For the horizontal asymptote, the degrees are equal. So we look at the leading coefficients. They are implied to be 1 here. So my horizontal asymptote is y equals 1 over 1, which is 1. All right, let's factor this to come up with our other pieces. On top, they don't have anything in common that I can pull out, but I can square root it, the difference of squares identity. The square root of x squared is x. The square root of 9 is 3. Whenever you square root something, you need a plus and a minus. In the denominator, the leading coefficient is 1, so I can just say to myself, what two numbers multiply to -8 and add to 2? That would be +4 and -2. Anything that cancels out creates a hole. So in this case, nothing cancels out because it has to be an entire set of parentheses. Anything left in the denominator is a vertical asymptote. So I have a vertical asymptote at -4 and at x equals 2. And anything left on top is an x-intercept. So I have an x-intercept at -3 and at +3. So you can have multiple vertical asymptotes, multiple x-intercepts, multiple holes, or you can have none of all of these things. There's only one horizontal asymptote or none. Last example, let me give you something that's more challenging to factor. Okay, so horizontal asymptote, let's compare degrees. 2 versus 3, it's a bigger degree in the denominator, so my horizontal asymptote is y equals 0. Now I need to factor everything. Reminder, we do the bottoms up method, so to factor the numerator, you bring your 2 to the back. 2 times 2 is 4. And now I can say, okay, what two numbers multiply to -4 and add to -3? It's called bottoms up because I need a bottom here. That 2 is my bottom. If you can simplify your fraction, simplify it. 4 over 2 is 2. If you can't, or after you simplify, if you still have a fraction, bring the bottom up. All right, so that factors the top. So I have x minus 2 and 2x plus 1. In the denominator, I just pull out what they have in common. I can't square root it because cubed is not a square rootable term. So pull out what they have in common. They have a 4 in common, and they also have an x squared in common. I'd be left with an x and a minus 2. All right, there's a hole there because those x minus 2's cancel. So there's a hole at x equals 2. There's a vertical asymptote with everything that's left in the bottom. You can either treat this as two separate things, or you can treat it as one whole thing. Either terms, either way, if you square root that, x equals 0 is your vertical asymptote. And then x-intercepts anything left on top, any factor left on top creates an x-intercept.